testing the video. All right, let's go ahead and read to your neighbor. Go, and I will minimize all of that with the cards. All right, let's summarize. On the back of card number 4, I am going to summarize the whole rule for finding absolute minimum and maximum. So here I go. And I'm going to start going over a question pertaining to this in about 30 seconds. Start writing.
Is this like the back of 3.1A?
It's, yes, back of 3.1A or card number 4 for me.
Oh, we're not getting another flashcard? No, it's just that one we did yesterday.
So here's the front, card number 4, and here's the back.
You should write that probably. Does that say CU?
CN, as in critical numbers. I'll go over this. I thought my handwriting was, mediocre. I'll do better. Castro, right?
I don't have enough. I just memorize it.
You just memorize it? Okay.
It's gone pretty well for me.
Okay.
I haven't used
I'll take it. So when we're on card number 10, I could tell you what's on the back of 7, what's in the front of 2, and you'll just kind of list it all out. Got it. You're on recording too, so proof.
All right. We can play it back at the end of the year.
There you go. So we're at like 1 minute and 59 seconds. All right, so I'm going to read. The first thing that you have to do for critical numbers, in case the wording was overwhelming, is you find the derivative, set them equal to 0, and typically we're going to factor. And you'll find your critical numbers that way. The undefined part, we'll do an example like it. That's going to typically happen when you have a variable in a denominator, because you can't divide it by 0. Right, Grant? And then we make our T-chart. What up, Sam? Mm-hmm.
Hey, Sam.
You gotta whisper. Whisper.
Is there any way I can take a picture of my test and send it to the...
No.
Okay.
No. Test don't worry.
Uh-huh.
Love you, Sam.
Now, the reason we're including the endpoints is because the example I gave you, would you agree that's the absolute minimum?
Yeah.
So we have to test the endpoints because it can be the absolute minimum or the maximum. Okay, let's do an example now. So A and B is going to involve some work. C, no work because it's a parent function. So let's see how we can actually use this. Step number 1, you need to find the derivative. So f prime of x. What is the derivative of the first component here?
12x cubed.
12x cubed. Very good. And what about the second component?
12x squared.
Oh, minus 12x squared. And then we're going to set this equal to 0. But before I do, let's factor. Between these two, I have 12 and something to factor out. 12 and x squared. So I have remaining x minus 1. When I set that equal to 0, we have the first one equal to 0 and second one equal to 0. Hopefully, if I take 0 divided by 12, it's still 0. If I square root the 0, it is still what? So our critical number is going to be x equals 0. What about x minus 1 equals 0?
Be 1.
1. So let's go to our step 2. Step 2 says to make a t-chart.
Wait, so the critical numbers are x equals 0 and x equals 1?
Mm-hmm. And that's by the factor. And let's write out the critical numbers. And I'm going to look at rule number 3. Rule number 3 is I have to include the endpoints. What is my endpoint given on part A? -1 and 2. Because your endpoint could be the absolute minimum or maximum. Sometimes none, but typically it does happen. When you're plugging this number in, we have to plug it back into the original. So I'm going to write out the equation right here so that you're not looking at the derivative equation by accident. So let's plug it in. We have f of 0. And then we have f of 1, f of -1, and f of 2. Someone's on their phone, and I'm not okay with it. Put them away. I'm sure that person's very sorry, right? Give me a nod. Okay, I figured. So we have, when I plug in the 0, I'm going to produce 0. Are we okay with that?
Yes.
When I plug in the 1, because 1 is positive, our coefficient will not change. It's simply 3 minus 4, which is -1. But since we have a -1 on the next one, I am going to write out all the tedious steps. Because that's where the silly mistakes happen. And we all make mistakes, and that's okay. So when I further simplify on this one, I get -1 to the power of a positive number. It's going to give us a positive 1, correct?
Yes.
Or even number, I mean. So we have 3. But when I have -1 to the power of odd number, that's going to give me -1. But I have another negative in front of the 4. So I have +4. So that results in 7. Ethan, come get the other portion. Now let's plug in the 2. And for 2, I do want to plug it in again. We have 3 times 2 to the power of 4 minus 4 times 2 to the 3rd. And let's worry about these two parts first. So we get 3 times 16 minus 4 times 8. That's going to give us 48 minus how many? 32. And that's going to produce our final answer as 16. So then, our final numbers that we can compare with are the following. Which one has to be our absolute minimum? -1. The lowest number is -1. Absolute minimum. What value is our absolute maximum? 16. So if you can factor, plug things back in, and do your simple math, you're good to go. Any questions on this?
That's it?
That's it.
Oh.
So all that wording, that was it. Why not, right? I know. Wait till you get to college and read a bunch of textbooks. That's why we're summarizing it. And I'm kind of training your brains to kind of see it in a different way. All right. Part B is going to involve something with the undefined. So let's go ahead and take our rule. Step 1, find the derivative. What is the derivative of 2x? 2. The next piece, I know it's going to produce a negative. And because we have that ugly fraction, when I bring that to the front, doesn't that eliminate the coefficient of 3 at the same time? So I have minus 2x. And 1 less is -1/3. I want to rewrite this because at some point when I set this equal to 0, I don't want to work with negative powers. So we have 2 minus 2 all over the cube root of x. So looking at my card, it says set it equal to 0 and make it undefined. I want to do the undefined piece first because that one's faster. Looking at this right here, where is my variable in my fraction? Top or the bottom? What are we not allowed to divide by on the bottom? Not a radical, but x cannot equal what? 0. So we know If x is equal to 0, it is undefined. And I'm going to go ahead and write that in parentheses so you know where that came from. And then I have to set the whole equation equal to 0 as well. So going back to my card. I found when it's undefined. I need to now find when it's equal to 0. And I'm going to take a tedious method. Every single step is going to be shown on this one. And if this were to be on your quiz or test, I'm going to give you a friendly one. This is not that friendly. So set this equal to 0. And then I'm going to go ahead and move the second piece over to make it, again, friendlier. So I added the second piece on both sides. And then I want to go ahead and make this over 1. Can we all cross multiply from here?
Yeah.
So when I cross multiply, here's what I get. And something nice about what is happening on the left and the right. What is identical? So when they cross out, is it producing 0 or the understood 1? The understood 1. So that means no matter what is cube rooted, has to be 1. What is that value? 1.
So just x equals 1.
X equals 1. And I'm going to make my T-chart all the way over. You guys know I write kind of big. I kind of want to blame it on you guys and say I write big because of you guys. But that's not true. You know what? I'll take that. And then the function is always from the original, not the derivative. So let's write out that function. And what do I also need to include in my T-chart? The endpoints, the interval, the close interval. So let's plug it in. We have f of 0, f of 1, f of -1, and 3. Now, 3 is going to be kind of ugly that you'll never see on your assessment. But I do want to go over that with you guys because why not? It is together. So when we plug in the 0, because every component has an x, and we plug in that 0, what is that going to produce?
0.
For the 1, it's really not going to matter, right? Because as long as it's positive 1, I could take my coefficient and write out 2 minus 3, which is -1. Is everyone okay with that? If that bothers you, plug it in. But as long as you have a positive 1, it's not going to change the value with the variable. For the -1, I want to write out 2 times a -1 minus 3 times a -1 to the 2/3. Because the piece that might be scaring you a little bit is probably right here.
Wait, why is it only on f of 1?
Mhm.
Why is it -3?
Why is it -3? No matter what 1 I put here, as long as it's a positive 1, this whole value becomes 1 still. So -3 times 1 is still itself of -3. Yes? Circle part? Let me do that part. So we have, at this piece, we know 2 times -1 is -2. Is everyone okay with that? So I'm going to explain what that 2/3 is really doing. And let's leave that -1 or -3 as it is for now. So we have the square on the top means it is squared. The bottom is cube rooted. So when I take -1 times -1, what does that give you?
1.
No matter what I do with the positive 1, what's my resulting value? 1. And that 1 times -3 is just -3. Okay? So that means that value is going to give me -5. The next piece that, again, unless you have a calculator, it's going to be hard to do, but I'm going to teach you approximation. Let's plug it in. 2 times the 3 minus 3 times the 3 to the 2/3. And let's do the left side, which gives me 6. And I'm going to leave that 3 as it is because I want to mainly talk about this guy right here. What is 3 squared?
9.
All right, so I'm going to write something out. We need to figure out what is cube root of 9. What our brain does know is cube root of 8. What is cube root of 8?
2.
Isn't 9 barely above that? And we know it's not a clean number. So we're going to pick some number that is close to 2, but right above. Give me any number.
2.9.
2.9? I'll take 2.9. Could you say 2.1 if you want it?
Yeah.
So I think it's closer to 2.1 more like, because 9 and 8 is pretty close. I want to stick with 1. If you pick 2.9, our answer will not change, meaning the absolute minimum and maximum is not going to be hindered. Ooh, there you go, Ian. Go up. So let's go ahead and see what we get. We get 6 minus, that's going to give us, is that 6.3? Is that right? And then that will result in negative 0.3.
I thought when it's like the denominator, you divide it.
You denominator, you divide it. Where's my denominator?
Like when you did like 3 squared, which is 9. Why didn't you divide it by 3?
Because 3 is not the main fraction. If it's a power division, it is a root.
Oh.
All right, let's circle our final result. We got 0. We got negative 1. Someone's talking over me. Negative 5 and negative 0.2. Where's my absolute minimum?
Negative 5.
Mm-hmm. And where's my absolute maximum?
0.
And again, that number did not hinder your final answer. Okay? All right. Now let's look at the one that involves pretty much no work as long as you know your parent function of your trig. Sine of x is our parent function of our sine function. If you remember on the sine parent function, what was the highest number and the lowest number that it went back and forth last year? Yep, negative 1 and 1. There we go. Uh-huh. And sine, did it start on the top or the middle?
Middle.
Middle. And it behaved in this manner. And just by looking at this, can we all say that is our absolute maximum? Can we all say this is the absolute minimum? So without doing any work, because we know the parent function, absolute minimum is negative 1. Absolute maximum is 1, and that's it.